Welcome back to this video. This is a continuation of the C# beginner series. If you are new here, please subscribe and click on the notification bell so that you are updated on new videos. In the previous video, we talked about methods in C#. If you have not watched that, I encourage us to do so. So let's get into the video. Classes in C#. A class in C# is a blueprint for creating objects. Now, what this means is that it defines the characteristics and behaviors of objects. In the next video, we'll be looking at the difference between a class and an object, but just for now, see it as a blueprint, like a plan for what you want. A plan where you say what are going to be the characteristics and you say what will be the behavior of a particular thing or an item. So when you want to use a class in C#, you need three things at a bare minimum. It will have the access modifiers, it will have the class keyword, and it will have the class name. Let's look at that. So now, when you want to have a class, basically what, as we've said, is you need a modifier, an access modifier. As I've said, we'll be looking at access modifier in a subsequent video, so just keep that for now. The next thing is the class. It must be class. You can't use any other thing. When you want to declare a class, you must, after your access modifier, you must put in a class. And after that, you now give it a name. So I could give it, let me give it class name. This is the bare minimum for a class. As you see, we have the curly bracket. You know, in C#, this curly bracket, they just define what is within the scope. So for this class, what is within the scope of this class is actually this, what this curly bracket is identifying here, just like with methods also. Let's go back to the slide. So as we've said, that the class keyword is compulsory and the class name is actually just the name of the class, whatever we want to use to identify that particular class. So within the bounds of a class, there are things that exist there or could exist there. These are called class members. So class members could constitute any of these four. The first is a field, and a field are variables that hold data that belongs to that class. We also have properties which encapsulate the private field. I will take these two together, and because in C# over time it kept improving, these two have been merged to be the same. They have been collapsed together. So previously in C# we have a field. So a field is just basically our variables. So for example, I could have an integer of ID. This is a field. This is basically what just a field is. So this field is contained within this particular class. So it is a field. Now, then we could have a property. Now, the property encapsulates this particular field. So for example, I could have a property called, let's call it, and the property must have the same type as the field. So ID, let's call it ID property, and basically you have your get and you have your set. This is how a property is in C#. The property encapsulates, so what it encapsulates is the field. So what field is it? So this will just return an ID, and usually, more often than not, this is just how it is. So you see that the property encapsulates the field. So it means that if you want to do anything with this ID, you will need to go through this property. That's why they say it encapsulates the private field. Now, this is something that you do for all fields. So if I have another field called, let's say, int, I will need to do the same thing for it. I will need to create a particular property for that also. Now, but because this is something we always will use and we always do, and you see it's almost always the same thing. except that, for example, here, if I'll put in the private field that I want to represent here. So what we have, instead of doing this, is we could just have, so you can use this prop shortcut, prop and then tap, and then it takes you there, prop and then press the tab key. It will have the shortcut, and this, so this is just, and I could have the same thing like this. So what this does, it encapsulates, this is like a property that encapsulates a private field. So behind the scene, there is a private field for this particular property. It is auto-generated for us. Instead of having to do all of that internally, it actually has a private field that it actually attaches to this particular property. So this is how we do it now in C#, and this is how we are encouraged to work with properties and fields in C#. So we also have the constructors. Now, the constructor is used for initializing objects. Now, when you have a class, as I've said, is a blueprint, right? So what the constructor does is, it is a means to, when you are telling them, whenever you want to use these blueprints to actually make a construction, to actually do something with this particular blueprint, these are the things that need to be set. This is how it needs to be done whenever you want to do that. So, you know, whenever you want to, as the word says, constructor, whenever you want to construct this class, you need to have put these things in place. So that's basically what a constructor is for. So now, for a constructor, the way it is shown is that it must have a public, and then it will have, not necessarily it's compulsory to have the public, but just it's more often than not public. So, and you have your class name, and then this. The name here, as you notice, is the same name as the class name, and that is how the compiler identifies what a constructor is. So for example, here we have this constructor that will be used to set up whenever you want to set up this particular class. So let's say I want my ID, as I've said, to be 3. So here I am telling that whenever you are constructing this class, ID should be set to 3. Basically, that's what this constructor is actually informing the system, the compiler rather. Also important to note is you can have more than one constructor. So for example, let's say you can have a constructor that has class name and it takes in an integer, and then we can now have ID is equals to this. This is being passed in from our constructor, and it is going to now be assigned to whatever this particular property is. So it's important to know that in constructor you can have more than one constructor in C#. Now that is for that situation. So the constructor's major function is to initialize the properties or items that we have within our class. That's the primary function of a constructor. So for example, let me just use a real world scenario. We have a class, let's have a class called a car. Let's have a car, and you know, a car has some properties, some things that we can associate with a car. For example, the car usually have speed. A car has a particular speed. So let me use this property, as I've said we'll be using. So public int, and then we have the speed. We have our getter and setter, basically. So a car will always have a speed, and we can now say that the initial speed of a car is going to be 0, for example. So what we are saying is, when you are constructing a class, that at the beginning it is set towards 0. The speed at the beginning is always set to 0. That is basically what we are saying here. That whenever you want to create this particular car starts with a speed of 0. And if it's not so, if it was 50, I'll say, okay, this particular car starts with a speed of 50. And that is what this particular constructor does. It says that whenever this car is to be constructed out, the speed will start at 50. Basically, that's what this is. So, and then finally we have methods. These are used for performing actions or tasks. So as we've shown in the previous video, when we have a method, our method signature, so let's just have public. Let's say this our particular car has to perform an action. So it means, for example, when you are driving a car, you have the throttle. I'm not sure, I don't know much about cars, but I do know that you need to press I think it's a throttle to speed up the car. So let's have a function for that, or a method for that. So we just have throttle, and then we pass in the new speed. So what you are trying to say is, okay, I want to increase the speed of this particular car. So what I'm saying, I want to just say return the new speed plus the speed. Or rather, I could just say that, yes, return the new speed plus the speed. That's what I want when you throttle. Because what happens when you throttle is that the speed will increase. So in that case, what we could have is that the speed is equals to new speed plus whatever was in the speed previously, and then we can return that particular speed. So instead of doing this, I could just use our operator shorthand for that new speed, and then we have that we are saying that whenever the throttle is pressed, the speed should increment. We want to have a faster speed for the car. And then we have the brakes also, so we could have public int, let's say brake reduce by speed, and then we could have that speed should be reduced by this value, and then we return what our speed is. So basically, this is a method that is performing a particular action. So in this class, we have a property called speed. We have our constructor that sets the speed to an initial value of 50, and then we have actions that this particular car class can perform. It can perform the throttle, which is going to just increase the speed of the car, and can perform the brake action, which is going to reduce the speed of the car. So in other words, speed is a property of a car. It's a characteristic of a car. A car must have a speed, a particular speed, for example. Whereas throttle and brake, these are actions, these are behaviors, the way the car will behave when it is throttled. It is a kind of like a reactional thing. So in a particular class, we will have behaviors and we will have characteristics or properties. So the properties or characteristics, those are properties, and then those are properties in C# rather, and then the actions or behaviors that we expect on certain situations are what we have in our methods in C#. So here we say that the methods are for performing specific actions or tasks, as we've shown in the previous video what methods are. So these are the members that constitute any particular class. It's not compulsory for a class to have all of these. As I've shown earlier, a class can do without having any of these actually, but more often than not, our classes will have any of these, or most often than not, we have all of these. So this is the class in C#. I hope this was clear. In the next video, we'll be looking at, okay, since we have this blueprint, how do we go about having the actual data or actual object, as it were. So when you talk of a blueprint, then there must be an actual implementation for that blueprint. We'll be looking at that in the next video, where we talk about classes and objects. I hope this was clear, and I'll see us in the next video.